Frozen yogurt is a refreshing tangy dessert that combines the flavors and textures of ice cream and sherbet. Raw materials. The primary ingredient in frozen yogurt is milk and milk products. Milk fat generally makes up between 0.5 to 6% of the ingredients depending on whether the frozen yogurt is non-fat, low-fat, or regular. Milk fat lends richness to the yogurt and is the synergist for other flavorings. Milk solids, not fat, MSNF, makes up between 8 to 14% of frozen yogurt. MSNF must be balanced in inverse proportion to fat for the best body of the product. MSNF consists of about 55% milk sugar, or lactose, 37% protein, and the remaining 8% are various minerals. The protein element increases the smoothness, viscosity, and compactness of the frozen dessert and makes it more resistant to melting. Sugar makes up between 15 to 17% of the ingredients. Sucrose, in the form of cane or beet sugar, is generally the primary sweetener, though other sweeteners are often combined. Sugar not only adds sweetness to the yogurt but also improves the body and viscosity and increases the concentration of total solids, TS, in the product. Total solids add body and texture as well as food value, since solids take the place of water in the mixture. Egg solids may be used for solids with the added benefit of decreasing the amount of time necessary for freezing the mixture. Stabilizers, in the form of animal and vegetable gelatins, are added to the frozen yogurt so that it maintains a smooth consistency in retail outlets, where temperature changes can coarsen the texture. Stabilizers reduce crystallization, hinder melting, and improve the handling properties of the frozen yogurt. Emulsifiers are used to help blend liquids that are generally immiscible by creating smaller air cells throughout the mixture. Generally in the form of fatty acids, emulsifiers also add firmness to the body and reduce the time needed to whip the mix. Although stabilizers and emulsifiers occur naturally in milk products, small amounts are usually added, making up only 0.5 to 0.6% of the entire mixture. Other ingredients added in small quantities include egg solids, color, mineral salts, and caseinate derivative, such as citrates and phosphates. Additional flavors include fruit extracts, nuts, cocoa, vanilla, sugars, and spices, such as allspice, cinnamon, cloves, nutmeg, and ginger. The manufacturing process. Processing the mix. The ingredients are selected for freshness and quality. They are measured in precise quantities according to the particular recipe. Liquid and dry ingredients are combined separately. The liquids are poured into a vat, mixed together, and heated. Next, the dry ingredients are added to the liquids in a particular order. Meanwhile, the batch is stiffed and the temperature gradually increased. Most ingredients must be incorporated before the mix is heated to 120 degrees Fahrenheit, 49 degrees Celsius, so that the mix does not become lumpy. The mixture must be heated to dissolve and blend the ingredients. Pasteurizing the mix. Pasteurizing the batch is necessary to destroy pathogenic bacteria and to help preserve the finished product. It is also required by law in most regions. Pasteurization is a simple process that involves quickly bringing the mix to a high temperature for a specified time and then quickly reducing the temperature to less than 40 degrees Fahrenheit, 4 degrees Celsius. The trend in the industry has been toward increasing the pasteurization temperature to about 175 degrees Fahrenheit, 79 degrees Celsius, for about 25 to 40 seconds. For greater results, batches can be pasteurized at temperatures as high as 210 degrees Fahrenheit, 99 degrees Celsius, to 220 degrees Fahrenheit, 104 degrees Celsius. These high temperatures also improve the flavor and help blend the ingredients more effectively. Homogenizing the mix. Homogenizing the batch makes it smoother, primarily by decreasing the size of fat globules to less than 2 micrometers. Without homogenization, fat could rise to the top of the mixture and create a layer of cream. Homogenization consists of pumping the batch through a small valve and against an impact ring. Three forces are at work. As the mix passes at a high velocity of about 30,000 fpm, feet per minute, through the valve, shear forces begin to break up the fat particles. The impact ring ruptures the fat further. Completing the process is cavitation, in which vapor bubbles are created by a sudden discharge of pressure. Within the bubbles the fat droplets crash against the vapor walls and disintegrate, thus, the more fat, the more homogenization required. Inoculating with yogurt culture. While the temperature of the mix is 90 degrees Fahrenheit, 32 degrees Celsius, it is inoculated with 1% yogurt culture. The mix remains at this temperature until it sets and is ready for cooling. Cooling and aging. After homogenization, the mixture must be cooled. If it is cooled slowly from about 90 degrees Fahrenheit, 32 degrees Celsius, to about 40 degrees Fahrenheit, 4 degrees Celsius, the mix will become more viscous. Once the temperature falls between 32 degrees Fahrenheit, 0 degrees Celsius, and 40 degrees Fahrenheit, 4 degrees Celsius, the batch is stored in aging tanks inside coolers. The mix is aged for up to 4 hours. Flavoring, coloring, and freezing. The final ingredients are mixed together in a flavor vat. These include sweeteners, flavorings, and coloring. This mixture is then pumped into the freezer with the rest of the mixture, which is about 20 degrees Fahrenheit, -6 degrees Celsius, to 28 degrees Fahrenheit, -2 degrees Celsius. While the mix is hardening, it is agitated to incorporate air and create overrun or excess volume. The addition of air also smooths the consistency and creates a more palatable product. In about 3 minutes the mix begins to freeze, and within a few more minutes, the desired overrun, about 50%, is achieved. About 1 to 2/3 of the water freezes during this stage. Packaging and hardening. After the desired overrun is reached, the mixture is packaged and placed in freezers where the freezing process continues.